So we're trying to locate the absolute extrema of the function on the closed interval. So to do that, we need to first identify the critical value. So what we're going to do is, this is really fairly straightforward. We're going to go ahead and find the derivative of the function first. That's our first step. So f prime of x equals negative 2x plus 3. So once we have our derivative, we have to set it equal to 0 so we can figure out where the slope is changing from positive to negative, because those are our turning points or our critical numbers within the interval. So we're going to go ahead and set it equal to 0. So this was step 1. And now this is step 2. We're going to go ahead and solve this. We get negative 3 equals negative 2x, and x equals positive 3 over 2, or 1.5. And since 1.5 is in our interval, that's great, and that makes things easier. So we are going to be, and so now we have numbers to check. So the numbers we need to check are x equals 1.5, this number right there, and we also need to check x equals 0 and x equals 3. These are our endpoints, and we always have to check those. So now that we have those numbers, what we're going to do is we're going to check them by plugging them into our formula. So we've got our function there. We're going to take the points we found to check, and we're going to check them all in the original function. So here we go. Let's use green. I haven't used green yet. So we're going to say f of, let's start with 1.5 because that's our critical number in the interval, equals negative 1.5 squared plus 3 times 1.5. And that gives me, and I'm going to just negative 2.25 plus 4.5, which gives me 2.25. So that's one check. We're going to keep going. So I'm going to check 0, switching colors. F of 0 equals negative 0 squared plus 3 times 0, which is equal to 0. Then I'm going to check my last number, which was f of 3. And so I'm going to get negative 3 squared plus 3 times 3. So that's going to give me negative 9 plus 9, which is also 0. So what we've done is we've figured out that the following things. At x equals 1.5, we have a max, which is 2.5. So we have f of 1.5 is a max, or 1.5 comma 2.25 is our maximum value. And then we have two minimums at 2 points at x equals 0 and x equals 3. We have minimums. The minimums are 0, 0 and 3, 0. And so those are our two minimums. We have a maximum at 2.25 and a minimum at a maximum of 2.25 and a minimum of 0 and 0. Remember, there's 3 different ways to say our maximums. One of them is 2.25. The other one is f of 1.5, and the third is 1.5 comma 2.25. So I didn't write down the f's of, so I'll just go ahead and underline in black for my max. That's my max. And my minimums are underlining in red. Those are my two minimums. So that's what we're doing. It's fairly straightforward if you're okay with derivatives. So always, these are our steps. Step 1, find the derivative of the original function. Step 2, set the derivative equal to 0. Step 3, take the answer to the derivative equal to 0 and the endpoints, plug them into the original function to see which one has the largest value and the smallest value. And that's how we find our critical numbers and decide which one's which. Good luck today.